Okay. Hi, everybody. A very good morning. So, well, let's please just wait for 2 more minutes so that they will just join and make me host, and then we can start. Okay. I'm the host. Cool. So, as I said last class, we completed almost all the reactions. Not almost. We have completed all the reactions which are there in aldehydes and ketones. We just have to see carboxylic acid. But before that, let us do some questions. Right. Okay.
Sir,
Yeah. Yes, Kana.
sir, I didn't attend the past few classes, sir.
Okay.
So I may not know all the questions.
No issues. No issues. Okay. 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 Let me share my screen. So let me write it as carboxylic acid, but we are actually going to solve some questions. Okay. So first question is, if I ask you CH3, one second, guys. Okay. So if I give you CH3, CHO, CH3, CH2, OH, and CH3O, CH3, and I have CH3, CH2, CH3. Okay, and I ask you to arrange them in the order of boiling points. Okay, arrange these things in the order of their boiling points. So this is not ketone, this is ether. Hope you understand that, right?
So should it be from lower to higher or higher to lower? So
Sorry,
should it be from lower to higher or higher to lower?
anything, whatever you want, however way you want. So which is going to have maximum first? Can you tell me at least? Which is going to have maximum value of boiling point?
CH3
The
OCH.
last one, sir.
This one.
So
That is going to
CH
have max. CH3.
OCH3.
This
Sorry.
one.
So if the last one has the most carbon, it'll have the highest.
I'm asking which is going to have
CH3
maximum.
CH3 CHO has most boiling. More
This
boiling.
has the maximum boiling point. Okay. Right. Any other answers? I got this one as answer, this one as answer, this one as answer. But what about this? Anybody want to tell that this is the answer, sir? This is going to have more boiling point. Okay. So people, this is aldehyde, right? This is ether and this is hydrocarbon. And this is what? This is alcohol. Correct? Which should have the highest boiling point? What are the criteria for boiling points? One is molecular mass, right? The other one is inversely proportional to branching, right? And the third and the most important point is what? Hydrogen bonding, right? So out of these four, which can involve in hydrogen bonding?
CH3
Second
CH2
one.
alcohol.
Only alcohol, obviously, because we know we need to have a OH bond present, right, for the hydrogen bonding to happen. So in none of these three, that is the first one, third one, and the last one, there is no hydrogen bonding possible, but an alcohol hydrogen bonding is possible. So first rank goes to alcohol only always, right? Okay, now that is the first one. Okay, which is going to have the minimum of boiling points? Which is going to have minimum boiling point? Maximum is this alcohol, which is going to have minimum boiling point. Right. So see, you have to understand that it is all about
Last one.
Last one. Okay, that's correct. Why? Yeah.
Because of no hydrogen bonding.
Okay, this also doesn't have hydrogen bonding. This also doesn't have hydrogen bonding. Why are you going for
Because
this?
aldehydes and ethers have higher boiling point than hydrocarbons.
Yeah, that's exactly why. Why is it that aldehydes and ethers have more boiling point than hydrocarbons? Why? So people, for answering these kind of questions, right? Maybe these things are not included in this particular points which I gave you, right? Remember this, okay? See, we have a liquid in which the particles are very close by, okay? And we are boiling it, heating it, so that they are going to go away from each other. Gases. This is gaseous phase. This is liquid phase, right? So what you have to understand is here between two liquid molecules, I'm going to have some very strong force of some attractive force will be there, okay? And that attractive force would have been weakened, and they're going to trying to go move far away from each other. That's what is happening, right? Okay. So can I tell the strength of the attractive force? The strength of the attractive force is directly proportional to the boiling point, because if at all I'm going to have very strong attractive force, then I have to heat it very strongly. I have to go for higher temperatures. That is what is boiling point. Is it not? Right? So the strength of the attractive force decides everything. Right? Now, what are the different kinds of attractive forces we can have? First of all, we can have Van der Waals force, right? Or we can have something called as dipole interactions, right? Dipole interaction. Or the third one you can have is what is your hydrogen bonding. Okay, and obviously hydrogen bonding of them is the strongest one. Then comes dipole, and then the weakest of them all is Van der Waals forces. Okay, now we know what are the criteria you have to look for hydrogen bonding. That we already know, right? Like hydrogen donor should be there, hydrogen acceptor should be there, and then only can have hydrogen bonding. Okay, now for dipole interaction, please understand that this is possible only in the case of polar compounds. For example, in the case of aldehydes, it is possible. For aldehydes and ketones, it is possible. Now you understand that there is a C double bond O. I know there is a difference in electronegativity. I can have a del positive on this carbon, del negative on this on this oxygen. Say second molecule you take, again we have carbon, oxygen like this. So we have a del plus, del minus. Again, you see that del minus, del plus, I can have an attractive force like this. This is nothing but your dipole-dipole interaction. This is one dipole. This is second dipole. The attractive force existing between these two dipoles is what is called as dipole-dipole interactions. Okay. So in any kind of polar compounds, right? If at all you have polar compounds, they can have dipole-dipole interactions, right? And van der Waals forces exist only in non-polar compounds. You know, that means there is no difference in electronegativity. Right? And van der Waals force is the weakest amount of force. So whichever is going to be non-polar, for them, they will have only van der Waals force. So even at lesser temperature itself, I'll be able to go for boiling because the force of attraction is not that much. Right? Okay, so that is the reason why. Excuse me, I have to drink some water. Just give me one moment. Okay. Right. So what I was trying to say is, so you understand that this is a non-polar compound. All hydrocarbons are non-polar compounds, so they will have only van der Waals force, right? So since among them, this is polar because I have a COC bond is there, okay? And I have here also it's polar because I have a C double bond O is there, okay? So, and this molecule is obviously polar, it is having hydrogen bonding also. So no issues. This is going to be the strongest force, and that is why it is having the maximum boiling point. And this is going to have the fourth rank. That is the last rank. That means, why? Because it is going to have the van der Waals force, that is the weakest of all the forces. Right? Okay. So now we have to decide among your aldehyde and your ether. Okay, we have to decide among aldehyde and ether. Now, how do you choose this? Right? Now, you understand that there is two carbon, one oxygen, hydrogen atoms are almost fine. Everything is fine. Right? Now it is all about how much polarity they have. Right? Both of them can have dipole-dipole interactions. Okay, this can have dipole-dipole interaction. This can also have dipole-dipole interactions because both of them are indeed polar. Right? But which is going to have a stronger dipole-dipole interaction, that particular molecule will have a higher boiling point. That is understood because again, this point only, same thing, strength of the attractive force, more and more is there, more and more will be the boiling point. So let us investigate. Okay. So people, we have say the COC bond. Okay. Now obviously oxygen is more electronegative. Okay. So let me write it as CH3. Okay. So we know that oxygen is going to have a del positive and carbon, these two carbons are, del negative on oxygen because oxygen is more electronegative. Okay, so del negative on this, okay, and del positive on this and del positive on this carbon. All right. Now we have to compare it with what? We have to compare it with this CH3CHO, which is going to have, say, this is del 1, we'll write. Okay, this is del 2 positive. Del 2 positive, and the oxygen is going to have a del 2 negative. Right. So whichever del value is greater, wherever I'm going to have higher amount of charge, there the attractive force will be stronger, and that is going to have higher boiling point. Okay, right? So let us talk in terms of this del 2, maybe based on our oxygen only we'll speak about. Okay, based on oxygen, this is del 2 value. This is del 2 negative. We're talking about here. It is on oxygen. It is del 1 negative. Forget about carbon. Okay, both the side we have COC bond, only oxygen carbon, so not much this thing will be there. But we can understand that del 2 will indeed be greater, right? Del 2 will indeed be greater. Now let me tell you why. Because you understand that there are CH3s which are electron donating groups, right? CH3s are electron okay, all right, del 1 will be greater. Okay, anyways, so we understand that the CH3s are electron donating groups, right? Now here also I have one CH3 which is electron donating group, but in this case I have two electron donating groups. In this case I have only one electron donating group. Okay. Now electron donating group, what will they do to the oxygen's negative charge? Will they not increase the oxygen's negative charge? Already negative charge is there and they are electron donating in nature. So they will have increase in negative charge. The del negative will be higher here. And here in this case for the del negative, you have only single increase. Why only single increase? Because we have only one CH3. In this case, I have two CH3s. Okay. So keeping all this in mind, can I tell for sure that del 1 negative is indeed greater than del 2 negative? We understood why, because there are two electron donating groups here. Here I have only one electron donating group, increasing the electron density on the oxygen, right? So definitely del 1 is greater. So this is going to be more polar, right? The ether is going to be more polar and this is going to be less polar, right? And obviously less polar means lesser force of attraction, so lesser boiling point. So we can conclude the fact that this one, CH3 CH2 OH is going to have the maximum boiling point. Then comes ether, because that is more polar than your corresponding aldehyde CH3 CHO. And the least of them, the least non-polar species is nothing but your hydrocarbon, that is this. So this would have been the order of boiling point. I hope everybody is following. Okay. Right. Next, anybody has any questions? Everybody understood, I hope. Anybody wants me to repeat again? Is everybody okay?
Sir, in the book, it's given as aldehydes is more polar than this one.
Aldehydes are more polar than ethers.
Yes, sir.
How is it possible? We are investigating in a very correct way.
I saw the example 12.2 in NCRT.
Yeah, you might have maybe I'll look into this. Okay, I'll check this and let you know. Okay, but according to the investigation, according to this thing we saw, obviously this thing is more polar. Okay, I'll look into this and let you know. You don't have to confuse yourself for now. Okay, we'll see this. I'll let you know what exactly is the answer. Fine. Next question we'll do. Right. Oxidation of ketones. Okay. Okay. So I have pentan 2-one and I have pentan 3-one. Okay, I have pentan 2-one and I have pentan 3-one. Okay. Tell me a test. Tell me a test to distinguish this. Right? Say I give you two test tubes, one containing pentan 2-one, one containing pentan 3-one. Okay, both will be white color. They will not have, both of them will not have any color. Both of them are ketones. Similar smell will be there. So if I give you two test tubes, how will you find out? This test tube is only pentan 2-one, sir. This test tube is pentan 3-one. How will you tell me? That's what I'm asking. You have to do some test, right? Tell me, how do you do it? How do you do this?
Sir, is it iodoform test, sir?
Sorry, what?
Iodoform test.
Yeah, good, good. That's a good one, right? So look at this, people. Pentan 2-one will look like this. Okay, and pentan 3-one will look like this. Okay, now you understand, right? The moment you see this part, right? This is nothing but your alpha ketones, alpha methyl ketones. Sorry, y'all. This is definitely going to give you iodoform test. So the answer to this question is iodoform. Because I know for iodoform to happen, we need to have this COCH3. Another bond should be there. This particular entity should be there. C double bond O, and to that a methyl group should be attached. You understand here? This to the carbon and carbon, here a methyl group is attached. Here it is not. Right? So this will give iodoform test. So can you complete the test, everybody? Can you write the reaction for this? Iodoform reaction for this. What is the reagent which you have to use? What is the reagent used for iodoform reaction?
NaOH.
What?
NaOH, sir.
That's it, NaOH only?
NaOH,
Plus I2.
NaOH with I2.
NaOH plus I2. Okay, good. Tell me the products. What will be the products?
One will be CHI3, sir.
CH.
Okay, one product is CHI3. This is what is going to follow give your yellow color, right? And easily you'll be able to say, that is how you predict. If you form the yellow color only, that means it is giving the iodoform reaction. Okay, what is the next product?
It's a
CHI3.
OH in the place of CH3.
Exactly. In the place of CH3, this CH3 will form CHI3. In the place of CH3, all you have to put is a OH. That's it. So you just take this compound, instead of CH3, you put a OH. So let me start from here. From this case, CH3, CH2, CH2. What we are having is C double bond O, right? And we had a CH3 here. Instead of CH3, you put a OH. That's it. This is your acid. Okay. So this will give iodoform test, gives the yellow color, but this will not form anything like that. Okay, so whichever is not forming the yellow test tube is your pentan 2-one, sorry, pentan 3-one. Whichever is forming, giving your yellow color is your pentan 2. Okay, good. Next question. Say, if I give you propanal and propanone. Okay, I have propanol and propanone. Again, give me a test to distinguish. Propanol, propanone, a test to distinguish. Really? You told the difficult one and you're thinking so much for the easy one?
Same test.
Iodoform.
Same test.
Okay. Fine. Fellings. Yes, Fellings is a good one. Tollens.
Colin.
Fellings. All these things can be used, no? Because this is an aldehyde. Right? And this is a ketone. Is it not? Tollens and Fellings are given only by what? Only by aldehydes. Ketones will not give this test. Right? Is it not? We know what happens in Tollens. We know what happens in Fellings. Right? What is Tollens reagent? Can someone tell me what is Tollens reagent? How, like, what exactly is the name you give for Tollens reagent? What is the name of Tollens reagent? What exactly is Tollens reagent? Go back, take your book or take your note and tell me what is Tollens reagent made up of.
Ammoniacal
Ammoniacal silver
nitrate,
nitrate, right? Ammoniacal silver nitrate. That is what is Tollens reagent, right? How do you do this? AgNO3, silver nitrate you take, you make it react with ammonia. That is this is what is ammoniacal silver nitrate. NH3 with NH3 with AgNO3, silver nitrate. And what is it going to form? it is going to form this coordination complex plus, right? This is exactly your tolerance reagent. Okay, this particular complex is nothing but your tolerance reagent. Okay, Ag NH3 twice plus. Okay, and we know what is going to happen if we have a RCHO, right? And we have this Ag plus compound, whatever this compound, right? And I know this is a mild oxidizing agent, so this is going to convert it into acid RCOOH. And what is happening to Ag? Ag will convert it into Ag precipitate. So this is a silver precipitate or silver mirror, right? That's what happens in tolerance test. Okay, Felling's test. What is there in Felling's people? Felling's reagent. What is Felling's reagent?
Fellings A and B, sir. A
And we
is
have
copper sulfate and B is sodium potassium tartrate.
Yeah, very good. Right. So we have two things in Fellings. One is A, another one is B. A is nothing but aqueous copper sulfate solution. Copper sulfate dissolved in water, right? And B is sodium potassium tartrate. Sodium potassium tartrate. Okay. Now same thing will happen. Say we have the RCHO. In this case, all you have to mention is last time I mentioned Ag plus. In this time you'll mention Cu2 plus. Okay. And obviously again this is going to oxidize your aldehyde to acid, and this is going to get reduced. This will get reduced to Cu2O. And I know this is going to be a red precipitate. Again, this is all you have to mention. Okay, you have to take propanol. Okay, you have to take propanol and write. If at all you choose tolerance, you have to write the tolerance reaction. If at all you choose Fellings, you have to write the Fellings reaction. Right? Chumma mentioning tolerance or Fellings just will not fetch you the entire full mark. Right? Obviously, propanol is going to be a ketone. Right? What is the structure of propanol? CH3, C double bond O, CH3. It is not going to give, whereas propanol, that is CH3, CH2, CH2, CHO, will give tolerance in Fellings test. Okay, these kind of questions are very, 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 very common in this chapter. They'll give you two things and ask you to distinguish them, what test you will use. Okay,
So
and actually someone said iodoform, right? Iodoform actually also will work. Right, in this particular question, iodoform will also be okay answer. This is a good one. Why? Don't you see that we have a COCH3 here? This particular component is there, but in this case it is not there. We have what? CH2 attached to C double bond. Right. So iodoform reaction is also a good way to go about it. Okay. So for this, three things can be answered: either tolerance, Fellings, or you could have also gone for iodoform.
So I have a doubt, sir. Why can't you go for reduction, sir? Aldehyde will be first degree alcohol, ketone will be second degree.
Correct. You want me
We
to
can use that also, sir.
Okay. If you form alcohol, then what will you do? You have to go for Lucas test. Right? Once you go for reduction, again, second step you have to do. You have to go for Lucas test. Lucas, primary alcohol will give very, very fastly turbidity. Secondary alcohol will give turbidity after 5 minutes. That is okay, but there is a two-step process. First, you have to go for reduction and then do the Lucas test. But these are not single step. You will be able to predict them. Okay? Understood?
Okay, sir.
Yeah. Fine, good. So that's about this question. Next question. I have CH3CHO, okay, and I'm using dilute NaOH. What is the product form? What reaction is this?
Aldol condensation.
Aldol condensation.
Exactly. This is alveolar condensation. Right? You know the shortcut, how to do this, right? So tell me, what is the final product? I hope you remember the shortcut. You have to use 2 molecules of, they didn't mention anything. So it is understood that it is where you have to use 2 molecules of this. Like even if they don't mention this, it is understood. Okay. Okay, so I think you have gotten the answer by this time. Hope you remember the trick. You should, yeah, tell me. Yeah, this is aldol only. I'm just asking about the product. What is the final product? Right. So we write it like this. We'll protrude the oxygen this side, C double bond O this side, and you have to protrude this side what? Alpha hydrogens. Right. This is your alpha carbon. Right. So we'll write it as H2CH CHO. This is your alpha carbon. 2 alpha hydrogens will be protruded. Then you will remove this H2O minus H2O to form what? A double bond between this carbon and this carbon. So you form CH3, CH double bond CH, CHO. That's your final product. Okay, right. Then if I ask you this one, okay, this question is okay. If I ask you, I have HCHO reacting with NaOH. What is the answer?
Salt.
What is it? Someone said something I didn't hear. What did he say? Okay, right. So anyways, what reaction is this, people? HCHO with NaOH? This is also aldol condensation. Is this aldol condensation?
So we'll get HCOH and CH3OH.
Oh, correct. The answer is correct. We are going to get HCOOH and CH3OH. What is the name of the reaction? It's a name reaction, right?
Yes, sir. It's not aldol condensation, sir.
It is not aldol condensation. Okay, it is not aldol. Okay, what is in there?
It's a Caniaro reaction. Caniaro.
It's called Cannizzaro. Right? It's called Cannizzaro reaction. Hope you remember, people. Cannizzaro reaction is given by aldehydes or ketones, which doesn't have alpha hydrogen. Aldol condensation. See, reagent is same. NaOH, there also NaOH only. Right? But whichever is having alpha hydrogen will give aldol condensation, and whichever aldehyde or ketone doesn't have alpha hydrogen will give you Cannizzaro reaction. Right? I know what is going to happen in Cannizzaro. This is a disproportionation reaction. Hope you remember. Disproportionation. What is disproportionation? One compound will be there. That compound will get oxidized. The same compound will undergo reduction also. Oxidation, reduction, same compound. So HCHO oxidized to acid, HCHO reduced to alcohol. Right? Same thing is going to happen in the same compound. Okay, this is nothing but Cannizzaro reaction, and that is what is the product. 2 products you will get, HCOOH and CH3OH. Cannizzaro. Okay, fine. Next question we will do. Okay. So I want you to convert propanal to butanol. Okay. I want to do this conversion. Propanal to butanol. See, if you, butan, they should be mentioning the number, but you know, since it is going to be a ketone, it is possible only if I have the second carbon to have a C double bond O. This is the only possibility. CH3, C double bond O, CH2, CH3. The second carbon can only have C double bond O because it is ketone, right? Second, or if you can tell me, so this can have, if you do that again, it is going to be same, butan 2 only. Okay, so this is the structure. Okay. Okay, butanone means butan 2-one. It is understood. CH3, Cu double bond O, CH2, CH3. Propanol, hope you all know the structure, CH3, CH2, CHO. I have to convert this into this. And you have to convert them not more than 2 steps, only in maximum 2 steps, not more than 2 steps. Okay, someone sent me something. No. So people, what you have to understand is you are having only 3 carbon atoms here, but you are having 4 carbon atoms here. Okay, right? So the number of carbon atom is increasing. Tell me what is the best method, like not only in this reaction, any reaction you take, if I have to increase the number of carbon atoms, there should only be one reagent which comes to your mind. What reagent? Not only in this question, any question where if you want to increase the number of carbon atoms, what is the reagent which you'll use? What should strike your mind always? Which strike your mind? Which reagent should strike your mind? If at all I want to increase the number of carbon atoms. Really? Everybody is thinking.
Sir, Grignard reagent.
That's good. That's good. Yes, Grignard reagent is the one which should come to your mind. Okay. Now that I've given you some clues, can you work on that? Now you are sure that we have to use Grignard reagent. Okay.
We should reduce propanol to alcohol, and then react with Grignard.
Wait. Grignard reagents will react with alcohol, or Grignard reagent will react with aldehydes and ketones?
With
What will
aldehyde
happen?
and ketone, sir.
Yeah.
It reacts with
React with
aldehyde and ketone to give alcohol, sir.
Exactly. Right? The Grignard reagent will react with aldehydes and ketones to give alcohol. Right? Obviously, the number of carbon would have increased. That is for sure. Right? So now you can increase the carbon atom by increase the carbon atom and convert it into alcohol if you use Grignard reagent, and that alcohol which you form, then what you have to do for you to convert it into an aldehyde or ketone, then what you have to do? If you want to convert an alcohol into an aldehyde or ketone, what will you do? What you should do?
Oxidation,
Alcohol.
sir.
Sorry?
Oxidation.
Yes, oxidation. Right? Primary alcohol can be converted into aldehyde. Secondary alcohol can be converted into ketone. Right? That is oxidation. You said reduction. That is aldehyde or ketone to alcohol is reduction. So this should be opposite. Oxidation. Alcohol to aldehyde or ketone is oxidation. Right? So yeah, now I've told you the entire answer. Just tell me the reagents, how you will do it, all those things you show me.
So I have one doubt, sir.
Hmm.
The reagent for oxidizing ketones can use LiAlH4.
That is reducing agent. No? LiAlH4, NaBH4, H2 bar nickel, all these are reducing.
K2Cr2O7, sir.
K2Cr2O7 you can use. KMNO4 you can use, yes. Because I'm going to get a secondary alcohol you can use. Okay. But if it was primary alcohol, which you would have got, right? And if I use KMNO4 or K2Cr2O7, what will we get? I'm asking you, I have a primary alcohol right? And if I use KMNO4 or K2Cr2O7, what will be the product? Will I get aldehyde or something else?
Yes,
Acids, sir.
What?
carboxylic.
Yeah, we will be getting carboxylic acids. Okay, because they are strong oxidizing agents, right? So people, let me tell it to you. For example, say if you have CH3CH2OH and I went for say KMNO4, the product is not going to be aldehyde. It is actually going to be carboxylic acid, CH3COOH directly, right? But if at all you want to convert this into CH3CHO, that is this is the an aldehyde. If you want to stop with aldehyde only, what should you use here? That is also oxidation. This is also oxidation, but this is a strong oxidizing agent. So I have to use some weak oxidizing agent. Any example for weak oxidizing agent?
Pyridium, PCC.
Yes. Good. PCC should be used. Okay. So PCC is pyridium chlorochromate. That is a mild oxidizing agent that will be able to oxidize your primary alcohol into your aldehyde. Right, so it is better to in this reaction also, since it is even though I'm going to get only secondary alcohol, it is better to write the oxidizing agent as PCC. Don't take KMNO4 or K2Cr2O7. Okay, the better answer would be to take PCC only. Okay, right. So I think most of you, I hope that you would have gotten the answer by this time. So people, let me help you here. CH3, CH2, C double bond OH. That's what we have. Right now we are seeing that here I have 3 carbons, here I have 4 carbons, so I have to take only 1 carbon extra, right? So in the Grignard reagent also, from the Grignard reagent we need only 1 carbon, so we will take a Grignard reagent which is having only 1 carbon, because that is enough for me. I just need only 1 extra carbon, right? And obviously you would have predicted that the Grignard reagent used should be CH3MgBr or CH3MgCl, whatever you want to have. Excuse me, I just drink some water. Okay, right. Now we know how the reaction goes, because I know that this is going to act as a nucleophile, the CH3 minus, and then this is an example. This is a very good example for what kind of reaction? This reaction we are seeing is an example for what kind of reaction? What kind of reaction is this? Sorry, what is it?
RNJ, Grignard reagent.
Yeah, that is okay, right? In general, I have something, a negative charge, and that negative charge attacking the carbonyl carbon. What kind of
Nucleophilic.
Nucleophilic what?
Substitution.
Substitution, is it? Is it substitution? Are we substituting one nucleophile or another nucleophile?
Nucleophilic addition, sir.
Nucleophilic addition reaction. Good. Right, because we're just adding the nucleophile, right? This nucleophile is going to come and get added here, and the C double bond O breaks, and obviously you have to add a H plus also, right? So now what is going to happen? We would have had CH3, CH2, CH. We have an O minus, and to this, the CH3 coming from your Grignard reagent would have gotten attached. Very simple, right? And then obviously you have to take a H plus, right? And then that will eventually become what? CH3, CH2, CH, OH, CH3. Now you got your alcohol. Now you can easily convert this into your butan 2-one by what? By doing oxidation with PCC. So you will form CH3, CH2, C double bond O, CH3. This is nothing but a butanol. Okay, 2 steps. You should not be including adding H plus and all as a step. Okay, this comes along with this. H plus you can put it here itself. Right, so that is going to come. Okay, very simple. Right. So another thing we'll see. I hope everybody is following. I hope nobody is having any problems. If there's anything, please let me know. Okay. So if I ask you, I have this particular ketone with me, and I'm making it react with NH2OH, right? What is the product form? Okay, first question. What is NH2OH called as? It has a name, right? Can someone tell me what is the name of this NH2OH? Okay,
Hydroxyl.
fine. Okay, good. It's called hydroxyl amine, right? NH2OH is what is called as hydroxyl amine. Okay, fine. So can someone tell me what is the type of reaction?
We
What is the type
reduce
of
H2.
We will be removing H2O, correct? Okay, but what type of reaction is this? We studied this under what? Under what type of reaction? Okay, so you're telling that we have
Nucleophilic
to remove.
additions.
Yes, this is also an example for a nucleophilic addition reaction. You know, you don't have to go for the mechanism. I can show you, because now you understand that the lone pair on the nitrogen will come and attack here, and then the bond breaks. But you don't have to go into the mechanism, because but that is the mechanism. Okay, whatever I'm trying to tell you, that is the mechanism. But we have a shortcut, right? We have a shortcut to write the product. Hope you remember, we saw something called as NH2Z. These are nothing but ammonia derivatives, is it not, from NH3? I remove one hydrogen, right? And I put some other group, Z, right? That is what these are, what are called as ammonia derivatives, right? You know what is the shortcut you have to follow for, making the product. Right? Do it. I'll give you maybe 1 minute time and some 2 minutes time. So if somebody got the answer, you can send me in WhatsApp, I can check. So someone already gave an answer. I have to somehow remove H2O, right? But how you have to exactly remove H2O, that you have to tell, right? I'll be back in 10 seconds. Okay, I'll show you that. Okay, this is what we have. Second. I hope I guys doing. Anybody send me anything? No, I didn't get anything. What is the thing? Whenever you have this C double bond O, right? This is what is the C double bond O. Okay, and how will you write the NH2Z? You will write it as H2NZ. This is how you will write. Whatever the Z is, keep it this side, and the two hydrogens on the nitrogen, that is going to get removed, right? So you remove H2 and O like this to form what? To form the two bonds, carbon having double bond with nitrogen, and to that nitrogen the Z should be attached, right? So in this case, what is Z? The Z is nothing but OH here. Isn't it? Right? So now what you have to do, if I can just write it properly. So we have your C double bond O here, and then we write it as H2NOH. That's what we have. And what you have to do is remove the water molecule to form what? This one, having a double bond with nitrogen, and that is having OH. Okay, fine. This is called as hydroxylamine. What is the product name? They are called as, whenever I have the C double bond NOH, those kind of compounds are what are called as what? What are called as? Okay, they are what are called as oxines, right? Hydroxylamine reacts with aldehyde or ketone to form what? Oxines. These kind of compounds are what are, I don't know the exact IUPAC name. Just want to know what are the types of the compound. This type of compounds are what are called as oxines, right? And hope you remember the trick, right? H2 from nitrogen, oxygen from the carbonyl compound you remove and make a double bond between this carbon and this nitrogen. Very simple. Okay, say another example like that. If you give you will do, say I have this particular ketone and that is reacting with NH2, NH, benzene ring with one NO2 here, another NO2 here. Okay, tell me what is the product. Right. Okay, people. I hope you know what is this compound. One second, I'll just read it. There's something. It looks weird. 1 second. H. Okay, fine. So first tell me, what is this compound called as? This is again similar nucleophilic addition reaction, ammonia derivative, because you understand NH2 is there, NH3 should have been there, the hydrogen is replaced by the entire thing. This is your Z. This entire thing is Z, right? Other than NH2, whatever is remaining is the Z. So what is the name of the compound here? What is the name of the compound? Go through your notes. Don't sit idle. Don't look at this thing. Go check your book, check your notes, and tell me what is the name of the compound. Only then you'll remember. If I tell you, how will you remember? If you don't know, then you check. You understand, then you'll always remember that thing. Right? Go for it. Go search in your textbook. Go search in your notes, whatever you have, and then tell me what is this.
Dinitrophenyl hydrazine.
Okay, it's called 2,4 dinitrophenyl hydrazine. Yes. Okay, fine. That's okay. Now tell me the product. Once you're done, maybe everybody, once you're done with the product formation, you know how to do the product formation now, right? The same thing what we did last time, except the Z is changing here, right? Yes, I hope you should have done by this time, right? Anybody wants to send me? Or you can just check when I'm writing now. So we would have had this one, right? I am having a C double bond O like this. And how should you write this one? You should write it as H2N. The first one we'll write like this. This and this nitrogen will write it as H2N and then continue. NH. Okay, here we have one NO2. Another NO2 is there. It doesn't matter what is here. This is just a Z. So now you will remove the water molecule minus H2O to form the double bond between the carbon and the nitrogen. Double bond N, NH, then continue. Same thing. one NO2 here and another NO2 here. That's it. This is your compound. Final answer. Same thing, exact same thing. It looks very complicated, but it is not, right? Just because the compound is looking very complicated doesn't mean the reaction will be complicated. A very, very simple reaction. I hope everybody is following. Okay, right. Moving on. Okay. So there is a reaction. Okay, there is a reaction in which oh no, wait. Okay, fine. So there is a reaction in which we will be able to convert benzal. Okay, benzal chloride. I will be able to directly convert this into benzaldehyde in one step. Right? What is the step? Benzal chloride, right, can be converted into benzaldehyde in one single step. Okay, right? If you're wondering what is benzal, okay, actually it's benzal dichloride. Okay, they didn't mention this, but you have to understand that this is benzal dichloride. Okay, what do you mean by benzal? Benzal is nothing but benzyl. So I can call it as benzyl dichloride also, right? So what is benzal chloride? You have a CH that is having 2 chlorine atoms like this. Okay, this particular carbon is what is called as benzal carbon or benzyl carbon. Okay, right? So this is what we have, right? Benzene ring with 1 CH having 2 Cls, right? You want to convert this into benzaldehyde in one step. How do you do this?
So side chain algorithm. Yeah, we need to use side chain algorithm.
Side chain?
Halogenation.
Side chain halogenation. Okay, what do you mean by side chain halogenation?
Reacting with UV light rays and heat.
Okay, by that you'll be able to produce this. Say for example, I have toluene, right? I take toluene. Okay, now I know this is toluene, right? Now when I go for say Cl2 in the presence of H nu, right? This is nothing but your free radical halogenation, right? So what will happen? We will convert, say we'll replace 2 of the hydrogen with 2 chlorine, right? So you'll be able to get CHCl, CHCl. That is okay. But how do you convert this to this? Single step.
In one step or 2 steps?
One step. So the clue is geminal diols. There is some problem with geminal diols. I'll give you 1 more minute to think about it, and I'm going to give the answer after that. Okay, people. Whenever we have 2 OH groups on the same carbon, there is a problem. There is a problem because there's going to be high amount of repulsion. So what you have to do, the moment you form these kind of compounds, you have to remove water molecule. right? So you'll remove water molecule and make a double bond between whatever the remaining oxygen is there with the carbon. So you are going to form C double bond O with two more bonds. I'm talking about these two bonds, and I'm talking about this carbon and this oxygen having a double bond. Okay, this trick you can always use, always, right? You can, if at all you have two OH with the same carbon atom, that will never exist because of high amount of repulsion. It will directly convert itself into an carbonyl compound, either an aldehyde or ketone, depending on what are other two things. Okay, so the moment if I keep NaOH, 2 moles of NaOH, what is going to happen? Let us check, right? So if I give 2 moles of NaOH to this, what is going to happen? We will convert nucleophilic substitution, right? CH, OH, OH. This is what you get. Moment you form, what is going to happen? We are going to remove this H2O. And if you remove the H2O, you are eventually going to form your benzaldehyde. Very simple, or I can write it here also, right? You will form C, double bond O will be there between this one, and that is already having a hydrogen. That's it, CHO. That's exactly what you get. Single step. Okay, so whenever they give you these kind of two chlorides, the geminal dichlorides can be converted to geminal diols, and obviously they are unstable. Remove the water molecule to form your corresponding aldehyde or ketone. In this case, it is aldehyde. Okay, we haven't seen the reaction, right? We have seen the reaction also. Okay, so that is about this reaction, right? Okay. Right. Okay, so if I have benzene reacting with C6H5COCl in the presence of AlCl3, what is the product? What reaction is this, people? What type of reaction is this?
Friedel acylation.
Friedel-Crafts acylation. Good. Okay. So you basically all these are new electrophilic addition reactions, right? So this is nothing but what? This compound, if I write it properly, this is nothing but C6H5. That is nothing but benzene ring with COCl. Right? We know what is going to happen, right? The moment AlCl3 is there, that will take up the Cl minus to form this particular electrophile, and that electrophile is going to come and attack your benzene ring and remove the hydrogen. The hydrogen will be removed, right? And then you'll be able to go for the acylation. So the final product you might have predicted by this time, C double bond O, and that is again attached to a benzene ring. This is what is the final one. Fine. I hope that is also okay to you, right? Okay, if I give you this one, okay, we have a CH3 and NO2, okay, and I'm going for CrO2, Cl2, and then H3O plus. Fine, what is the product? Okay, maybe this looks very weird. Let me read on this again for you. Okay, one CH3 and one NO2. We are going for CrO2, Cl2. What is the product? So the moment you see CrO2, Cl2, what? Okay, first, what is the name of CrO2, Cl2, people? What name do you give? Okay, chromite, right? Okay, there is only one name reaction where we use chromite.
Etard reaction.
Etard reaction.
Etard reaction. Okay, good. In etard reaction, what do we convert to what?
Benzaldehyde. It's converted to benzaldehyde.
Toluene will be converted into benzaldehyde, right? So this is the toluene part. The CH3 part would have gotten converted into CHO. That's it, right? This would have been CHO. The NO2 stays as such. That's it. Nothing will happen to the NO2. This is your final product. This is your etard reaction. Okay. See, this questions were not asked in the previous years. Simple questions. Okay. Right. So next question. Okay. Say if I ask you to convert acetophenone to phenyl to butanol oil. Okay, acetophenone to phenyl to butanol or butan to all, however you want to write it. Okay, both are correct. 2-phenyl butan to all or 2-phenyl Q2 butanol, both are correct. Okay, I want to do this conversion. Tell me, how will you do this? First, acetophenone's structure you should know, then only you can proceed. Right? Can someone tell me how acetophenone will look?
Benzene ring attached with CH2CO.
Benzene ring attached with
CH2CO.
CH2CO. No, it's very simple. Acetophenone, right? That is C double bond O CH3. Correct. This is what is acetophenone. Okay, right, fine, go for it. And you have to convert this into, write the structure. Then only you will be able to answer this. Right? So we have butan to all. Let me write first butan to all. CH3, CH, OH, CH3, CH2, CH3. Right? But it is not there in the second carbon. The second carbon we have a benzene ring. Right? Second carbon is attached to a benzene ring. We'll write the benzene ring also. Okay, this is what is your 2-phenyl butan to all. You should be right. See, knowing to write IUPAC name when the structure is given. That is okay. When the name is given, you should be able to write the structure also. Like in the case of conversions, it will be very useful like this. Okay, so you have to go for this particular conversion. Again, you are seeing
Grignard reagent, sir.
Good. Okay, tell me what is the Grignard reagent used?
Sir, 2 carbons, so CH3, CH2, Mg here.
Good, very good. So people, you understand, right? Benzene ring, carbon, oxygen, CH3. Benzene ring, carbon, oxygen, CH3. This part is coming from the compound itself. What I'm having extra? I'm having extra only to be this. Very simple. So obviously that should have come from your Grignard reagent. No other go. Right? So if I can just write the mechanism for you. Right? So we have C double bond O with the CH3. We would have taken CH3, CH2, MgBr. So this would have been the negative charge coming and backing here. And then you go for hydrolysis also. Don't worry about it. And then eventually we are going to get, we have one COH would have been there. CH3 is already there. Now this CH2, CH3. This is going to come from the Grignard reagent. Like basically this can be written like this also. CH3, CH2, CH3, CH2, COH with the CH3 and this thing. Same thing. This is what you will get. Very simple. You'll be able to guess this. Right? All that you have to do is add a Gridlock reagent that is nothing but CH3, CH2, MgBr. Very simple. Right? Okay. I'll give you this reaction. Double bond CH C6H5 with ozone, zinc, and H2. Okay, tell me the products. You know what you have to do, right? In ozonolysis, this is, I think I told the answer. This is ozonolysis. The moment you O3, right? You know it is ozonolysis. I told you a shortcut to remember ozonolysis. What do you have to do? Can someone tell me the shortcut? What do you have to do here? People, what is the shortcut for ozonolysis? What is the shortcut? Check your notes, check your textbook, something you do and tell me what you should do in ozonolysis. What is the shortcut? Go on. What is the shortcut? I hope you guys are checking. Please don't sit idle. Check your textbooks. Check in. I don't think in the shortcut will be there in textbooks, but in your notes it would have been there. I've given you the notes. Please check there. You will understand. Not able to get? Right. So when we have this C double bond C, right? When we have the C, whenever we have alkenes, whenever I go for ozonolysis, we can easily make this, right? Wherever the C double bond C is there, break it and put C double bond O and C double bond O. That's it. You're going to get 2 moles of C double bond O is what you will get. Right? So the same thing can be done for this compound also. This is where I have the double bond, break it, put oxygen this side, put oxygen this side, right? So for this cyclohexane ring, directly, I am going to have one C double bond O, product number 1. Okay, plus what I'm going to get? Plus we have the, say, let's start with this 6C6H5, right? CH, and that is again attached to one oxygen double bond O. That is nothing but benzaldehyde. Right, C6H5, C double bond O with a H. Very, very simple trick. Wherever the double bond is there, break the C double bond C and put both side, C double bond O, C double bond O. Very simple. Okay, right. So fine people, I think we have solved enough number of questions today, right? Maybe next class also we'll spend some first half an hour on solving these questions, and then we'll go for carboxylic acids. Or maybe we'll finish complete carboxylic acid completely, and then we'll spend again one whole class on problem solving, something we'll do. Okay, anybody has any particular questions? Can we wind up? Any questions are there?
No, sir.
Okay, please do revise. See, organic chemistry, the thing, whenever I teach you, you will understand, right? But organic chemistry, easily you will forget. Remembering it is incredibly difficult. How will you remember? If you have to keep on looking into it, keep on practicing it. On a daily basis, at least half an hour should be spent on organic chemistry. I'll keep on forgetting. Right? Okay, people, I'll stop right here. Thank you so much. We'll meet again next week. I'm ending the class.
Thank you.
Thank you. Thank you.
Thank you.